Welcome everybody. Today we're talking about evaluating piecewise functions. So function notation is something that might be new for you. So equations can be written in a form called function notation, which we use as a quick way to name and evaluate functions with a given input when dealing with multiple functions. Remember, input are x values. So when you see an equation like this one, instead of that y equals, what we're going to write for function notation is f of x equals the 2x minus 8. So the way we read this is we say f of x equals 2x minus 8. So the way you read that is f of x. So what the parentheses when the x represent is the number that you're plugging in for x. So here it says evaluating functions. To evaluate a function for a specific value, substitute the value in for x. We're plugging the value in for x and find the output. So the output will be our solution for a graph using the given x value to find the output value, the y. So this first section says evaluate the following using the given functions, and they give us an f of x and a g of x. So frequently they'll use different letters to distinguish between different functions. So problem 1 says f of 2. So what that means is that we're plugging in 2 for the x in the function. So f of 2 goes with this f equation. So whenever I see f, I'm going to plug it into there. So f of 2 equals 3 times 2 plus 4. So I substituted the 2 in for the x in that equation. So 3 times 2 is 6. 6 plus 4 is 10. So my solution is f of 2 equals 10. And on a graph, what this means is the point to 10, because the 2 is the input, the 10 was the output. The next one says g of 2. So g is this equation. So when I see a g, I'm going to plug the number in for the x in that equation. So I'm plugging the 2 in for the x. So g of 2, I'm going to plug that 2 in for x, so 2 squared. So 2 squared equals 4. So I know g of 2 equals 4. So on a graph, that would look like the point 2, 4. Next one says f again, so we're going to plug it into the f equation. So I'm going to do 3 times 1/3 plus 4. So 3 times 1/3, 3 and 3's cross off, so I'm left with a 1, plus 4 equals 5. So I know f of 1/3 equals 5. And finally, the last one says g of 8. So I'm going to plug that into the g equation. So I'm plugging the 8 in for the x, so x squared. So 8 squared is 64. So g of 8 equals 64. So that's how it looks when you're dealing with equations. We can also evaluate functions on a graph. So on this graph, they've drawn a function, so it passes the vertical line test, so I know it's a function. When problem A says f of -4, the -4 is the x, and we're looking for what it equals, which is the output, which is the y. So on the graph, I'm going to go on the x-axis. So the x-axis is this one, and I'm plugging in this -4, so I'm looking for where is -4 on the x-axis. So -4 on the x-axis is right here. So if I trace that up to where it touches the function, it hits it here, and that's at the y value 2. So my output for that is 2. The next one says f of 0. So again, 0 is the x, so I go to where x is 0. Oh, and that hits right on the origin. So the y is also 0. For f of 2, the x is 2, so I go to where x is 2 and then trace to where it touches the function. So that y value is -2. And f of 5, if I go over to where x is 5 and trace down, that's hitting at -1. So y is -1 when f is 5. So what each of these represent, like this last one, that's showing that that's the point 5, -1. So on that function is the point 5, -1. So those are just like single functions, just kind of like a basic curve. So today we're also going to be introducing a new concept called piecewise functions. So a piecewise function is made up of 2 or more functions, each with its own domain. So domain is going to be like our x restrictions. And evaluating, so same as evaluating a function, but now we're going to determine which piece of the x value belongs to by checking the domain first. So that'll make more sense once we see it. So here, this is called a piecewise function because I've got two different parts to f. So I've got x squared minus 1, and that's when x is less than negative 2. And 5x plus 3 is when x is greater than or equal to negative 2. I'm pretty sure this is a typo in your notes, so make sure right here, make that a negative 2. I think in your notes it's a positive 2, so that was a typo. So this first function, these go together. So the things in line go together. So when x is less than negative 2, we're going to use x squared minus 1. And then when when x is greater than negative 2, we're going to use 5x plus 3. So when I look at f of negative 5, that negative 5 is my x. And when I look at my domain restrictions, which are these two things, negative 5 is less than 2. So because it's less than 2, I'm going to pair it up with this function here, because that's what I use when x is less than negative 2. So I'm going to plug negative 5 in for the x in that green equation. So I'm going to do negative 5 squared minus 1. So 25 minus 1 is 24. So f of negative 5 is 24. For the next one, negative 2 is my x. So notice both of my domain restrictions deal with negative 2, but this is exactly negative 2, so we should pick the one that's equal to it. So that's the pink one where it says x is greater than or equal to negative 2. So the equal is why I would pick that one. So then I would plug negative 2 into the pink equation. So I would do 5 times negative 2 plus 3. So negative 10 plus 3, so negative 7. Finally, 7 is our x, and 7 is greater than or equal to negative 2. So I'm going to plug it in. So it's 5 times 7 plus 3. So because it matches that domain restriction, that's the reason why we're plugging into that equation. So 35 plus 3 is 38. All right, let's try another one. So here we've got 3 different domain restrictions. So when I say domain restrictions, I'm talking about this right side. So those are those domain restrictions. So first it says g of 2. So if that's my x, I have to look at the domain restrictions and say which one does 2 fit in. Well, 2 is greater than or equal to 1, so I'm going to use that last equation because it fits that domain restriction. So I'm going to do 2 times 2 cubed plus 9. Well, 2 cubed is 8, so 2 times 2 times 2 is 8. 2 times 8 is 16. 16 plus 9 is 25. For negative 4, I know that's my x, so then I look up at the restrictions. Ooh, negative 4, so it has to be equal to it, so we're going to use the first one, so that's where x is less than or equal to negative 4, so it fits that restriction. So I'm going to plug it into the first equation. So 1/2 times negative 4 plus 3. So 1/2 of negative 4 is negative 2, and negative 2 plus 3 is 1. Finally, 0 is my x, and 0 is in the middle of negative 4 and 1, so it fits this restriction. So I'm going to use the second equation. So negative 0 minus 1. So the 0 really doesn't matter, so it's really like 0 minus 1, which is negative 1. So anytime they put a negative in front of the x, I would recommend doing parentheses. With 0, it didn't really matter, but it's just good practice to get into. All right, for our final equation, we've got negative 5 as our x, and negative 5 is less than negative 3. So I know it's going to fit that first restriction. So we'll do 3 over negative 5 minus 2. So negative 5 minus 2 is negative 7. And I can't simplify that, so it'll just stay the same. Next, 0 is my x, and 0 is between negative 3 and 6, so it fits the second restriction. So I'm going to plug it into the second equation. So 2 times 0 squared minus 3 times 0. Well, that one's kind of silly. You just times by 0, you get 0 minus 0, which equals 0. Then we've got x is 7. So 7 is greater than 6, so I'm going to plug it into the last one. Ooh, notice for the last one, this 8 doesn't even have an x. So if there's no x, that is simply the solution. So if it just gives you a number, that's it. That's all you got to do. Finally, we have f of 6. So that means 6 is our x. So we have to look for the one that's equal to 6. So that's the middle domain restriction. So where x is greater than -3 and less than or equal to 6. I'm going to plug it into the second equation. So 2 times 6 squared minus 3 times 6. So remember, you do exponents first. So 6 squared is 36. And we can multiply those together. So 2 times 36 is 10. Nope. 1 second. 2 times 36 is 72. I did my notes wrong. I wrote down a 3 instead of a 2. And then 72 minus 18 is going to give us 54. Everybody makes mistakes, even the teachers. Okay, so that is solving piecewise functions with algebra. So we also can do piecewise functions with a graph. So really, this is just like the one we were doing before. The only difference is now we have some open dots and closed dots. So let's look at this. So this says f of 2. So I know 2 is my x, and I'm looking for the y. So what it equals is going to be the y. So on the graph, I'm going to go to where x is 2, and then trace down to where it touches the line. So it touches the line here at y is -1. And the next one says f of -3. So I go to where x is -3. Ooh, if I trace that, it touches 2 different points. So one of those is open and one of them is closed. So the closed dot is the solution. So an open dot does not actually include that value. So our solution is going to be the closed dot. Oh, this one isn't very nice either. So this one actually is like in the middle. So we're going to call that 2.5. So if you want to write yourself a note, use the closed dot. So you're not going to use the open dot. So closed dot always wins. Next one, x is -1. So if I go over to -1, it's here. So it also has 2 dots, but they're both open. So if they are both open, there is no solution. So we're going to say does not exist. So DNE stands for does not exist. So if you want to write yourself a note, DNE stands for does not exist, because no solution exists there because they're both open dots. Finally, when x is -4, that's here. If I trace it to where it hits the line, that is where y is 2. So my solution is 2. Let's try another graph. So here, this one says x is 0. So if I go to where x is 0 and trace it up, that hits at 2. Then x is -4. So if I go to where x is -4, that's hitting at y is 1. Then at x is -1. That has an open dot, so we ignore the open dot and we go down to the closed dot, which is at -2. Finally, when x is 3, I trace to where it touches, and that is at where y equals 3. So I would recommend pausing the video now and trying out the next two on your own and then checking your answers. So next set, when x is -1, that hits right on the line, so that the y value would be 0 because it's on the x-axis. When x is 2, if I trace it up, it hits at y is 1. When x is 1, again, solid dots at 1. And when x is 0, it again hits at 1. So we got a bunch of 1s on that one. Final graph, when x is -4, it's on the x-axis, so that is y is 0. When x is 1, the solid dot is at 1, so we ignore the open dot that's down there. When x is 3, again, that's on the x-axis, so it equals 0. And when x is 2, we've got a solid dot and an open dot, so we ignore the open dot and just look to the solid dot, so -1. All right, that is evaluating piecewise functions. So I hope that helped, and good luck.